Okay, we're going to continue with the heart of algebra. This will be part 4. This part will be a little bit shorter. We're just going to do transformations of graphs and then compositions of functions. And then we'll stop there, and then we'll do the second part of the heart of algebra, which is linear functions. Okay, so transformations of graphs. This gives you just a simpler way to get a decent picture of our graph without having to use an XY chart or pulling out our graphing calculator. Okay, so first we're going to look at vertical and horizontal shifts of graphs. So it says suppose C is greater than 0. So you just have some number or constant C that is not 0 and it's greater than 0. Okay, so it says to graph y equals f of x plus c, shift the graph of y equals f of x upward c units. Okay, so you're going to be given a base function f of x, and this could be something like, let's say f of x is x squared. Okay, then f of x plus c might look like our base function x squared plus something like 4. Okay, so what we're going to do is we're going to take our base function x squared, we're going to move it up 4 units. Okay, to graph y equals f of x minus c, so that might look like x squared minus 4, we're going to shift the graph down 4 units. To graph f of x plus c, so notice now this plus c is in parentheses. Okay, so that would look like still using this base function x squared, x plus 4 squared. Okay, so notice the plus 4 isn't outside of the function, it's actually inside of your base function that's squared here. We're going to graph to the left 4 units. Okay, and then f of x minus c, that would be x minus 4 squared. We're going to go to the right units. Okay, so before we move on, if it is outside of the function, okay, it's going to be a vertical shift, and it's what you'd expect. Plus is up, minus is down. If it's inside the base function, so inside the parentheses, you have a horizontal shift, and it's opposite of what you expect. Okay, when you see plus 4 and you're moving a horizontal, you want to move to the right. That's just our reaction. Okay, but you're actually going to move to the left. Also, when it's minus, you would want to move to the left, but you're going to move to the right. So vertical shift is what you expect. Horizontal shift is actually opposite of what you would expect. Okay, example says use the graph of f of x equals x squared, g of x equals the absolute value of x, and h of x equals x cubed to sketch the graphs of each function. We've already graphed all of these functions earlier. I think it was in part 2, maybe part 1. You'll have to go back and check. This was x squared, and I'm just doing a picture. I'm not doing a window or anything. I just want a decent picture of these graphs. This is f, that's x squared. This would be g, that's absolute value of x. Remember, it was a v. And then h was just this curve, look like this. Okay, so number 1, it says j of x equals x squared minus 1. So we're using this base function x squared. The minus 1 is outside of the function, so we're going to be moving down 1 unit. Okay, so we're going to take this picture, we're just going to move it down 1. Okay, so instead of having this point at 0, we're going to have a point at negative 1. So move it down 1. Okay, so this gives us a good enough picture. So we could find the domain and range from this. We could find the minimum, local minimum. Okay, number 2, we have L of x equals x cubed plus 5. So we're using this base function here since it's x cubed, which I needed to put h here. Okay, plus 5 is on the outside, so that means it's going to be a vertical shift. So we're going to be moving up 5 units. Okay, so we're going to be taking this picture and moving it up 5 units. Okay, so 1, 2, 3, 4, 5. Okay, so this middle point here is actually going to be here. So there's kind of our changing point. So we have this picture. Okay, number 3, j of x equals x plus 3 squared. Okay, notice this base function is still the squared, okay, but the plus 3 is on the inside. Okay, so that means it's going to be a horizontal shift. Okay, remember for horizontal shift, it's opposite of what you want to do. So plus, you want to move right. So we're actually going to be moving left 3. Okay, so we're taking this picture, we're moving it to the left 3. So that middle point is here, you have something like this. Okay, number 4, we have L of x equals absolute value of x minus 2. Okay, now our base function is this g, since it's absolute value. Okay, you have minus 2 on the inside, so that's going to be a horizontal shift, and it is to the right 2. Okay, so it looks like this. Okay. Number 5, we have n of x equals x plus 2 cubed minus 4. Okay, first of all, our base function is this x cubed, so it's going to be the curve here. Okay, we actually have 2 shifts. This plus 2 on the inside is a horizontal because it's inside. Remember, horizontal is opposite of what we would want to do, so this would be left 2. Okay, this here is on the outside, so that means it's a vertical shift, so that means it's down 4. Okay, so we're taking this picture, we're moving it to the left 2, down 4. Okay, so to the left 2, down 4. Okay, so instead of the middle point or changing point being here, we're going to the left 2, down 4. Just moving that whole picture this way, so something like this. Okay, I'm going off the page there. Okay, we're going to do one more. Okay, so page 15, top of page 15, we have r of x equals absolute value of x minus 1 plus 2. Okay, so our base function is absolute value. We have a minus 1 on the inside, which is horizontal shift. That's going to be to the right 1. Now this plus 2 on the outside would be up 2. Okay, up 2 units. Okay, so to graph that, we want to go to the right 1 and up 2. So we have absolute value looking like this. Okay, stretching and shrinking, and we also have reflections here. Okay, if c is greater than 1, okay, so notice it's not 0 anymore, it's 1. To graph y equals c times f of x, stretch the graph y equals f of x vertically by a factor of c. Okay, so we're going to be stretching. If c is in between 0 and 1, to graph c equals f of x, we're going to shrink the graph vertically by a factor of c. The main thing for the stretching and shrinking is that the graph shape stays the same. It's just stretching or shrinking it a little bit. So the shape isn't changing. It's not moving at all. It's just stretching or shrinking. Mostly, I want you to look at this reflection, which is next. To graph y equals negative f of x, reflect the graph of f of x in the x-axis. To graph y equals f of negative x, reflect the graph y equals f of x in the y-axis. Okay, so if the negative is on the outside, we're reflecting in the x-axis. If it's on the inside, we're going to reflect in the y-axis. It's almost always on the outside. You will see it on the inside occasionally, okay, but most of the time it's on the outside, so you're going to reflect in the x-axis. Okay, use the graphs of f of x equals x squared, which we know what that looks like, and g of x equals square root of x, which we've also graphed that. So go back on your other videos if you're trying to remember how to graph those. Okay, number 1, we have g of x equals 3x squared. Okay, so we have a number here. There's no negative or anything. So what we're going to do is we're going to take this picture and we're going to stretch it vertically, meaning it's just going to be a little steeper. Okay, so since I'm not doing a window here, we really don't have to be too technical with this. We're just making this a little steeper. So we're taking the ends and we're pulling them up or stretching. Number 2, h of x equals 1/2 x squared. Okay, this is going to be shrinking because the number in front is 0 to 1. Again, it's not negative, so we're just going to be shrinking. So we're taking f and now we're shrinking it vertically. Okay, so it's not going to be as steep. Okay, again, since I'm not putting a window, we don't have to be really technical with these. So all 3 of these pictures, to me, look the same. So if it's not negative, just remember the picture stays exactly the same. You don't have to move it at all. You're just stretching or shrinking. Okay, now number 3 is different. We have negative x squared. So we have a negative on the outside. Okay, so coming back up here, negative on the outside says to reflect the graph in the x-axis. So we're looking at this picture, except we're going to reflect it in the x-axis. Okay, so instead, we're going to have something that looks like this. Okay, so if it helps, I'm going to go ahead and draw the original graph in dotted and reflect it. So as the x-axis being your mirror, you reflect it down. Okay, number 4, page 16, we have negative square root of x. Okay, we have a negative on the outside. I'm going to go ahead and draw the original graph. So the original graph, this is g, absolute value, I'm sorry, keep saying absolute value, square root of x. It's on the outside, so we're going to reflect it in the x-axis, so the reflection would look like this. Okay, and then number 5, we have L of x equals the square root of negative x. So here are the x's on the inside. Okay, so again, I'm going to draw the original as a dotted. Okay, now it's on the inside, so we're going to reflect in the y-axis. So now our y-axis is our mirror, so the new function will look like that. Okay, so that is just a simpler way to graph functions. If you just want to get a picture of the domain, range, minimum, maximum, where the window doesn't really matter, transformations are a great way to use. There's going to be a couple questions, just from what I've seen from the math SATs, there are a couple questions of transformations. So make sure you have vertical, horizontal, and reflections memorized. Okay, and then the last thing we're going to do for this section before you guys start on your first practice set is compositions of functions. Okay, so it says given two functions f and g, we can make a new function h called the composition of f with g, defined by h of x equals f of g of x, sometimes denoted as we say f composed with g. So you have this little sign here. Okay, example says let f of x equal x squared and g of x equal x plus 1. Find f composed with g of x and g composed with f of 2. Okay, so let's go ahead and do f composed with g. So we're doing f composed with g of x. Okay, by definition, that's just f of g of x. Okay, so we're just going to fill in. We're going to start in the middle. We're going to copy g of x here. So f of x plus 1. Okay, so instead of g of x, I just wrote in x plus 1. Okay, now f of x plus 1, this tells us x plus 1 is our input. Okay, so instead of inputting just x, we're going to input x plus 1. Okay, so our new function would be x plus 1 squared. Okay, I'm just going to come over here to the side. This last step here seems like students have questions on. So how are you getting that last step? So let me just go ahead and show you. We had f of x equals x squared. Okay, you can easily do f of 0, right? That's 0 squared. F of 2 is 2 squared. I'm just making up these inputs. F of y would be y squared. F of x plus 1 is x plus 1 squared. Okay, so whatever your input is, you just have to square it, okay, which is exactly what I did here. Now we want to do g of f of 2. Okay, so let's go ahead and do g composed with f of x first, and then we'll input a 2. So this would be g of f of x. So g of, instead of writing f of x here, I'm going to actually write x squared. Okay, so this says input x squared for g. Okay, so if we were inputting a 0, it would be 0 plus 1. If we were inputting a 2, it would be 2 plus 1. If we were inputting a y, it would be y plus 1. We're inputting an x squared, so it's going to be x squared plus 1. Okay, then g composed with f of 2 would be this function, except now we're using 2 instead of x. So what is that? 4 plus 1 is 5. Okay, next example, we're going to do the same thing. So it says let f of x equal 4x minus 10 and g of x equals x cubed plus 12. Find g of f of x and f of g of 0. Okay, so g of f of x, start on the inside, copy f. So g of 4x minus 10. Okay, now this is our input for g. Okay, so if we were to input 0, it would be 0 cubed plus 12. If we were to input y, it would be y cubed plus 12. We're inputting this whole thing, so it's going to be 4x minus 10 cubed plus 12. So 4x minus 10 cubed plus 12. Just going to leave it at that. We don't really need to simplify. Now we want to do f of g of 0. We'll start with f of g of x first. So start with the inside f of, we're copying g here, which is x cubed plus 12. Okay, now we're doing f of some input. So if we were to input 0, it would be 4 times 0 minus 10. If we were to input y, it would be 4 times y minus 10. But we're inputting x cubed plus 12. So that would be 4 times x cubed plus 12 minus 10. So 4 times the input minus 10. 4 times the input minus 10. Okay, so now we need to do f of g of 0. So this would be 4 times 0 cubed plus 12 minus 10. 0 cubed is just 0, so 4 times 12 is 48 minus 10, that is 38. Okay, so we're going to stop there. You need to go ahead and do practice set 1. Try all of these problems on your own first, and then look at the solutions. So please try them on your own first, then look at your solutions and check, and then we can go over the ones that you did not get correct.